The changing of one element to another is called transmutation. Consider common uranium. Uranium-238 has 92 protons and 146 neutrons. The nucleus loses 2 protons and 2 neutrons, an alpha particle. The 90 protons and 144 neutrons left behind are the nucleus of a new element. This element is thorium. An arrow is used to show that the U-238 changes into other elements. Energy is released in 3 forms: gamma radiation, kinetic energy of the alpha particle, and kinetic energy of the thorium atom. In the nuclear equation, the mass numbers at the top balance, and the atomic numbers at the bottom also balance. Thorium-234 is also radioactive. When it decays, it emits a beta particle, an electron ejected from the nucleus. When a beta particle is ejected, a neutron changes into a proton. The new nucleus then has 91 protons and is no longer thorium. It is the element protactinium. The atomic number is increased by 1 in this process, but the mass number remains the same. The beta particle, electron, is written this way. The -1 is the charge of the electron. The 0 indicates that its mass is insignificant when compared with the mass of nucleons. Beta emission has hardly any effect on the mass of the nucleus, only the charge changes. When an atom ejects an alpha particle, the mass number from the resulting atom decreases by 4 and the atomic number by 2. The resulting atom belongs to an element 2 spaces back in the periodic table. When an atom ejects a beta particle from its nucleus, it loses no nucleons. Its atomic number increases by 1. The resulting atom belongs to an element 1 place forward in the periodic table. A nucleus may emit gamma radiation along with an alpha particle or a beta particle. Gamma emission does not affect the mass number or the atomic number. The radioactive decay of U-238 to an isotope of lead, Pb-206, occurs in steps. On a graph of the decay series, each arrow that slants downward toward the left shows an alpha decay. Each arrow that points to the right shows a beta decay. Some of the nuclei in the series can decay either way. In 1919, New Zealander Ernest Rutherford was the first physicist to succeed in artificially transmuting a chemical element. He bombarded nitrogen nuclei with alpha particles and found traces of oxygen and hydrogen that weren't there before. Rutherford accounted for the presence of oxygen and hydrogen with the following nuclear equation. Many such nuclear reactions followed, first triggered by particles from radioactive elements. Later, scientists used more energetic particles, hurled by giant atom-smashing particle accelerators. The elements beyond uranium in the periodic table have been produced through artificial transmutation. Earth's atmosphere is continuously bombarded by cosmic rays, mainly high-energy protons from beyond Earth. This results in the transmutation of atoms in the upper atmosphere. Protons quickly capture stray electrons and become hydrogen atoms in the upper atmosphere. Neutrons keep going for long distances because they have no charge and don't interact electrically with matter. Many of them collide with the nuclei of atoms in the lower atmosphere. When nitrogen-14 is hit by a neutron, carbon-14 and hydrogen are produced. Most of the carbon that exists on Earth is stable carbon-12, and in the air, it appears mainly in the compound carbon dioxide. Because of the cosmic bombardment, a tiny fraction of the carbon in the atmosphere is carbon-14. Like carbon-12, it joins with oxygen to form carbon dioxide, which is then taken in by plants. All plants have a tiny bit of radioactive carbon-14 in them, and so all living things contain some carbon-14. The ratio of carbon-14 to carbon-12 in living things is fixed while the organism is alive. When a plant or animal dies, it stops taking in carbon-14 from the environment. Carbon-14 is a beta emitter and decays back into nitrogen, so after an organism dies, its percentage of carbon-14 decreases at a known rate. The longer an organism has been dead, the less carbon-14 that remains. Scientists can find out how long ago a plant or animal died by measuring the ratio of carbon-14 to carbon-12 in the remains. Archaeologists use the carbon-14 dating technique to establish the dates of wooden artifacts and skeletons.